Okay.
SD card. Anyway, so being as it is, that gives us the flexibility to try out new stuff. And one of the new things we like to try is Arduino seems to be a nice platform. It's low cost. It's only like $15–20 for one of the boards. And in the ET124, we bought a bunch of these boards. Looks like very similar to what you have.
Well, that red one we got from you. So.
Yeah. Well, this is yeah. You have kits. The various companies make their own kits. It's open source, which means companies like SparkFun can make their own variety. Arduino makes their own. There's a lot of other companies because it's open source, which means the design is for anybody to use. You don't have to pay a royalty, so it's kind of cool. So in ET124, we're starting to use this to introduce lots of interesting projects. And what's nice about this Arduino, it's a computer. It's very easily programmable by software that's also open source. And it's freely downloaded. And a company that worked with this also is this Autodesk company, which makes AutoCAD. And they came up with this 123D circuits program. It's a cloud-based software that you don't have to install any software whatsoever. And it includes this Arduino along with a breadboard that you can do electronics with. So I'll just jump into here and log in. So, and if you have any questions about Penn College or electronics, please let me know. I'm sure Mr. Sampson has told you all kinds of cool things you do, jobs that you can get. Tim's been through the curriculum himself, so you can kind of see there's going to teaching, which is kind of a good bracket or deal, call it.
Depends on where you're at. Just cancel that. It's the school district's crap. They have the worst network system.
So my particular background, like Tim,
Remember you on video.
I went to Penn College first. So did Mr. Kinley, actually, way back. Actually, Mr. Kinley is one of my first students. He had to suffer through the beginning of my teaching, and I, with a couple other students, went to RIT, Rochester Institute of Technology. We didn't have a four-year program back then, so a bunch of us went up to RIT, and some of us got our four-year degree there. And the job market was kind of low at that point. It was, at times you think it is similar like it is today, but actually for jobs in electronics, there's a big demand. Okay, so for other types of jobs, they might be tough to find, but for general electronics, there's a really high demand. So anyway, I went home after I graduated from RIT looking for a job, and a job came open at Penn College. It was a non-teaching job, and I had another offer from a company called Raytheon in Massachusetts. Interviewed for both, got both offers, decided to stick more towards home, and took a job at Penn College, turned into teaching a year later, and then Penn College encourages faculty to continue their education, and I, with some other faculty members, took courses at Penn State. I eventually got my master's degree, and then eventually got a PhD. So it took me a long time. I mean, it was like 23 years in college total to get the PhD, but you can do that if you want to. Penn College is a good stepping stone for lots of different goals. If you want to just get a two-year degree, get a job, and have a company pay for your schooling, that's an option for a lot of big companies. They'll pay for up to 1 or 2 or 3 classes a year, tuition-free, books, lab fees, everything. But it's on your own time typically, or at least mostly on your own time. Some companies actually give you an hour or 2 off a week if you have classes to go to, and they pay you for it. So instead of working 40 hours, you work maybe 35 because they allow you to leave early to go to school. So a lot of companies will pay for your continuing education. At Penn College, again, I just used that system. They paid for most of my tuition at Penn State, so that was kind of a good deal. Plus, they paid me more as I got more credit, so it kind of worked out that way. So that's a little bit of my background. I've been teaching now for actually going on close to 30 years now. I enjoy it and always learning new stuff. And so what this is here is a program. If I hit new here, there's 3 types of things that you can do. Actually now a 4th. It's called a mesh thing I just saw is brand new. But I'm going to go to electronics lab. Now, Mr. Sampson, has these students have done any electronics yet? Any basic electronics, like Ohm's law?
Oh, yeah.
Oh, yeah.
Yeah, this is groups, well, primarily group 2 with 1
Okay,
and 3,
so you've
because
been
we're
through
missing some.
Series, parallel, and all that
Yeah,
stuff.
yeah,
Okay.
yeah.
So everybody recognize this, right? What's this?
Breadboard.
Breadboard, okay. And, you know, this is a big one. And what's nice about this program, and you can, you know, zoom in and out, you know, however you want. I'm just using the wheelie thing here, or move it around, right? There's other components, just hit plus components, and you can bring up your components. Let's say you want a resistor, you can put a resistor here, you know, maybe a power supply, right handy. What else do we want here? Maybe a potentiometer would be nice. Okay. So you just drag up whatever you want. Now I kind of like the smaller breadboard here. We need a multimeter too. So let me bring up the smaller. There's a big breadboard. I like this one right here. So I'm going to grab this one. I'm going to bring that up there. And somewhere here I need it around. So this is a free program you can get. This is a free program. You just create a free account. There's an upgrade to it, but I don't know exactly what the upgrade would give me. So I'm just going to hit the delete key here and get rid of the big one.
And you guys will need to create an account in January for this, so pay close attention.
Yeah. So let's just say we have, I mean, the default, you can see if I click on it, it's a 1K resistor. So if I do Control C for copy, Control V, it pastes another resistor on it, right? And I'm sure we all know how to, I think is it R or Control? I think it's Control R. I think it's just R. Yeah, R does the rotate, or you can rotate up here, and you zoom in here. I don't know why I'm working really small here. So here's 2 resistors, and you know I can join these with a wire if I want, right? Just click and drag. Okay, come on. Yeah, click there for a wire. So these now are in series, right? And let's use the power buses. So I'm going to run a wire up here to plus, and I'll put a wire. Takes a lot of these to ground. So my power supply, I need to wire, you know, the plus here and the minus. I don't know why it's always crisscross, but it's crisscross. And you can change the colors. A lot of times we like to put black on the ground and red for your source voltage. Alright, and basically just hit simulate, and the default's 5 volts, and it gives us the current from the source, which is 2.5 milliamps. Does that make sense? That doesn't it, right? 5 volts and 2K, 5 divided by 2 is 2.5. So this looks correct, but let's hook up our multimeter. So you hit stop simulation, and what should be the voltage here at this point, okay?
2.5 volts.
Right, 2.5. So here's the negative lead. Stick this here. Well, let's put it right across. Let's put it right, like this. So let's look at this to the bottom part of the resistor, and this plus. Simulate again. I'm on volts, right? I can go amps, volts, or resistance on that multimeter. And there's 2.5 volts. If I want to do Control C, Control V, I can have the other multimeter, right? And positive, negative. It's just really cool. Whoops. I should put the positive lead. This was kind of cool. You can mess up all you want, and it's not going to
Oh, you're off,
resistor.
off a row.
Oh,
So you're negatively.
see? That's good. So it's pretty easy. Then I don't know what else we do with the potentiometer. I guess if you have potentiometer, I can replace, let's replace, getting R to reverse. Let's see, that's the middle wiper.
You're just hitting R to rotate?
Yeah.
Okay.
It's kind of wonky here. I don't know what it is. I guess I'll just plug it. So, I guess it's landing here. So instead of this resistor, let's put on a pot, right? So I need a middle wiper and one of the end
Oh, you can drag the wire.
wipers. And then if I hit simulation, you know, the voltage varies according to, right now, this pot's taking almost all the voltage, right? Because it must be a high resistance. So if I go over this way, it lowers the resistance. So now this pot, I take it to 2.5 or whatever. So now it's kind of back to that. So just, I guess it's a quick review of what you can do. So you can do your AC or DC's analysis, right? Now there's only a DC supply. So if you wanted to do things with a sine wave, then you'd have to, this does not have a sine wave source. So if you wanted to do something with AC circuits, you'd have to use this, what we call this Arduino. So I'm gonna go back. Let me
Okay, I don't have much time with this program, so you can't do anything AC, no AC inputs at all. I mean, as far as,
You just have to make it, well, here, let me bring up this circuit here. What you do is you just, that's where you take the Arduino comes in. You can make a function generator really easy. You just build a function generator with this code,
Okay.
right?
Okay.
You just have to have a, say you want a 1 kilohertz signal,
mm,
you generate a 1 kilohertz square wave, put a low pass filter on it to turn it into a sine wave.
Okay.
Filter out all those edges, you know.
I like I said, I haven't meant much. I didn't know if they had a frequency generator or anything
Yeah,
in
they
there.
probably will. As a matter of fact, what's nice about this, if you would search, you know, function generator, a circuit would come up. I mean, there's thousands, right? You can just do function generator probably, right? And just search someone probably made one public that you can snag.
Huh.
You gotta look for one that's actually legit. I'm not sure, you know. And then you have to look and see, but there's, you know, lots of projects that people have called function generator. So you can, mostly it's gonna be done in software, I think. But
I'm amazed this is.
normally, I would think a function generator, you would need probably like an op amp to do like a triangle wave, you know, like integrate it for triangle, I think, right? Yeah. Something, you know,
Mm-hmm.
but I don't know, if some of these, just like me, I had like, start an idea, I save it, and then it ends up on the search, so. So I'm gonna click here and go to my.
So anything you save ends up public,
I think you have
or?
to publish it first.
Oh, okay.
I don't know if mine, I think you have to, like, here's the one I wanted to go over here today, is this, thing called H-bridge. Well, this was the last lab that we did in my class, because, we did like a real beginning Arduino, and then I wanted to do something a little more interesting. So what we did is, followed this, example, here it is, experiment 15 from Adafruit, which is a company like SparkFun that has all kinds of cool makerspace projects and boards and things. And he has this one from Simon Monk, who's been around forever. That's done. Matter of fact, I think isn't this his? No, this is Forrest Mims. Okay, he's kind of like a Forrest Mims guy that's
Oh.
been around forever, doing. He must have